Welcome to my Switching, Routing, and Wireless Essentials course. This should be the CCNA version 7 curriculum. This is the second of 3 courses. Module 15 is about IP static routing. So we're going to be covering static routes, configuring static routes, setting up default static routes, floating static routes, and host static routes. There's a lot that we can do with static routes, and sometimes even if we're dealing with a dynamic network, sometimes we actually do want static routes, depending on circumstances. That's why we have to cover this material. So jumping right on in, static routes. A static route basically are used for implementation on a small network. This is true even if there are dynamic routing protocols already there. We can do static routes for both IPv4 and IPv6. The 4 main types are standard, default, floating, and summary static routes. And how we actually issue them, how do we create them, is we do it through IP route for IPv4 or IPv6 route from the global configuration command. Alright, so from there we will provide the details. So when we are looking at configuring a static route, we also have to look at next hop, like where is it going? So we can do it through a few different ways. The next hop can be identified as next hop, and that's via IP, via a directly connected interface, or we can do a fully specified static route, and that will be the next hop, IP, and exit interface. So here's an example. IP route, the network address, the subnet mask, and where we want to send it, either the IP address or the exit interface. And we can also set a distance if we want to. When we're doing floating routes, that's what we're going to do. And again, don't stress over it. We have labs going through how to configure this for each 4 of the main types. For IPv6, same thing, except we now do IPv6 route and then add the IPv6 prefix and prefix length, then the exit or next hop, and then distance. So for example, here we have R2, R1, and R3. R1 and R2 are connected, R2 and R3 are connected, and they are using both IPv4 and IPv6. This is known as dual stack. We can operate both IPv4 and IPv6 in the same environment. Here we have our route information for IPv4, and you'll notice that our pings for one of them work. For 172.16.2.2, it is directly connected, so we know about it. For things on the other side, past the router, that aren't directly connected, we don't know about them. So, in this example, R1 can ping R2, but R1 cannot ping R3 because R2 or R1 doesn't know about it. R2 doesn't know about R3's LAN. It knows about R3, but doesn't know about the LAN interface. For IPv6, same thing. We can see that it knows about directly connected routes, but anything past that, not really. So let's go ahead and let's talk about how do we configure our static routes. Again, we have labs walking us through how to do this, but this will give us at least the initial process of what we are doing. So here we have, let me grab my pen. All of the static routes will begin with IP route. It is saying match this IP and this subnet. Send to that address. So this is the next hop address. This is what we're matching. For IPv6, same thing. We have to make sure IPv6 is turned on. Then we say IPv6 route, match this address with this CIDR, and send out that interface, or send to that address. Here, we start listing the interfaces instead of the IP addresses. We can do either IP or interface or both. IPv6, same thing, we're telling it to send out of an interface instead of an IP address. Here we have fully specified static routes. It will actually say IP route, match this IP, this subnet, send out this interface, and send to that IP. This is, you can actually do a little better security if you're doing this route. That way, you can control traffic out of a specific interface, but either interface or address work just the same. So fully specified static route for IPv6, they will be using the link local address, the FE80 addresses between the two. Even though they may have a global unicast address, point-to-point networks will use the link local addresses, the FE80 addresses. So here we'll see IP route, the address to match, out serial interface, and it will go to the link local address. Fully specified static route, again, this is just IPv6 version of it. So how do we verify our static routes? Three main types: show IP static route, show IP route, show running config, and we can look at the IP route sections. If we're looking at IPv6, instead of doing show IP, it would be show IPv6. Again, IP denotes IPv4, IPv6 denotes IPv6. Next section is about configuring the default static route. This is what you're going to probably see the most on current networks that have dynamic routing protocols. So first of all, what is a default static route? Well, we can have something called a stub router or stub network, and that's going to be more of a branch. So what ends up happening is we can say match all packets, and we can set a default route if we want to. So routers commonly use the default route to either configure locally or learned from other networks. The default route is basically the router of last resort. So if it doesn't have a matching address in the route table, we can say send to our gateway of last resort. So we may have, you know what, I'm gonna get my pen. We may have a different cloud down here and a different connection. We can say anything going to the corporate network, send this way. Anything going to the internet, we can send through a different route. We can match the addresses for the corporate network, and we can say anything else go through the second network. So how do we do it? The nice thing is we do static routes by quad zeros. For IPv4, we do IP route 0.0.0.0 space 0.0.0.0, and again we either give it the exit interface or we give it the next hop IP address. For IPv6, we do a : /0. That says match. If no other matching addresses in the route table, this will match and send to or leave out this interface. So this is how we would configure it if our next hop is this address. We would do IP route /0 space /0, that address. If we wanted to do that as a interface, we could, and we could do the same thing with IPv6, again /0, and that guy can actually be either a link local address or it can be a global unicast address. So how do we verify it? You can always do a show IP route, and that's going to be the static route or gateway of last resort. If we are distributing this, it will then say go to router X, whatever router has the default route, and forward it out that way. So the gateway of last resort could be a different router depending on how we're distributing this. We actually will review how route distribution in a later video, because we do cover that when we cover OSPF. So the example below shows how we do it with an IPv6. This will show a static route via IPv6. So how do we configure floating static routes? If we have two ISPs, for example, how do we ensure that ISP 1 stays active? When ISP 1 goes inactive, we can have ISP 2 come inactive. That way, we always have a path leaving, we have a backup internet connection, and the routes should automatically learn. So these are what we do as floating static routes. We assign different weights on them. That way, we can have one route with one weight and one route with another weight. If the primary route goes down, the secondary route can take over. And essentially what we do is when we configure a static route, here we have static routes for both IPv4 and IPv6. The default weight is 1, so we don't have to put it. You'll notice there is no weight. Here we have our exit or our next hop space, we have a weight. Here our weight is 5. If the first route, if this guy goes down, it's no longer working. This route will be installed in the routing table. That way we have a route to disseminate to everyone else. We still have a exit interface. Here's an example of how we would configure it and test it. So moving forward, configuring static host routes. So this is more if we're mapping single hosts. So automatically installed when an IP address is configured on the router, it's configured as a static host route. Host routes automatically obtained through other methods, which we've already discussed several of them. So with Cisco iOS, automatic install host routes are known as local host routes. These are going to be distinguished with a L in our router table. So if we're dealing with directly connected routes, they're going to be C. If they're local routes, they're going to be L. Static host routes allow us to map specific addresses with a /32. If it's IPv4, /28 if it is, /128 if it's IPv6. So here is an example of a static host route. If we want to get to this address, we would list the address and we would do a /32. We can send it to the next hop or the exit interface. That way, if we are sending something to 209.165.200.2, for example, this route would not accept that. This route is only matching this specific host and nothing else. To verify it, we can do a show IP route, and we can see what static routes are learned. And again, we can see if they are host routes, if they are denoting a /32 or a /128. For configuring IPv6 static host routes, same thing. We would give it our address and we would configure it out to the appropriate interface. If we want to do a link local address instead of a global unicast address, you would delete the IP static route for IPv6 using the global unicast address. So it would be no space IPv6 route destination IP and prefix space next hop IP address, and we would replace that with IPv6 route destination or the matching address with the appropriate prefix, and then we can say what interface or what link local address. If we're doing a link local address, it is normal that we do a exit interface also. That way, if we have multiple link local addresses and they're matching, we know which interface they should actually be leaving. Questions, concerns, please reach out. Thank you.